Aiden, not here. Oh, there you are. They're kind of the same color. The straw throws it off, right?
A little bit. Yours a little bit bigger. They both even got that like silver lining on top too, so I almost got me. Rabbis.
Well, I'm gonna pull this out here.
He said no. Absolutely not.
That's wild.
That was record. Record time.
No, I'm serious.
We did? They in here?
You need two or one? I think there's one. You have So you just gotta get it.
Word of the day?
Just saying that we're giving it. Like, if you want me to say it. How we plan on being seen. I just need a side by pair. Chemicals or something happens. What?
Stay fine.
You gotta have a definition on the
Okay, if you guys haven't done so yet, you're going to need each of the papers up front as well as a calculator to get started with notes.
Daniel, not here? Bobby Lake? Lugo? Thank you, sir. Xander? Thank you, sir. Isabella? Not here? Poorly. That sounds like a bit. Is it a cocktail?
Okay, listen up quick. 1 second. Let me get your attention for 1 second. This is a lot of writing. Pretty much everything on this slide has to be written down. So I'm just going to give you guys a few minutes to copy it down before I start talking about it. The first line, this is what are some properties of gases? Don't write that. That's a sentence above it. You're going to write the 5 bullet points underneath it. So we'll take a few minutes, get that copy down, and then I'll kind of talk about it and we'll move on.
No, I changed it, I think. Let me double check.
I said hot dogs, shitter. Okay, that's all. Like, I got two, even though it's the last thing I put in there. Find a business. Like, so you can't have any kids.
Did anyone not get 2 papers?
Sit, I can-
You did? Okay. I get you one. Sure, you didn't get one either? You get one of these?
I got one. I saw it, but it got me. You know what I'm
I think when I did print it, I think I printed off 100. I can't believe those. I didn't expect we'd need over 50, but
Or someone grabbed 10 of them and wants to really study.
could have been the same thing as the suckers.
Might have been the suckers. Oh boy. That's healthy. Make sure we're copying these down. As soon as I kind of see everyone's done, I'm gonna start moving on. All right, let's do another minute. 1 minute, now moving on. If you're done, just sit patiently, we'll get moving. Who didn't get the second sheet, the Boyle's Law sheet? Anyone else not get this? You guys didn't? Really short. What? Sorry, like Okay, we're gonna get started. So since we're doing notes, if I can have everyone close their computer screens for the time being. We're gonna be on our computers later in class. Phones should be put away. We should only have about 20 minutes or so of notes, and then it's up to you guys to do your assignment the rest of the class. That's all I have for it. So some of these behaviors that it talks about. Gases expand to fill their containers. That makes sense if you guys think of an empty water bottle, right? There's gas in that entire water bottle. It's not just sitting at the bottom. It's not just pooled at the top. It's all throughout. They spread out easily and mix with others. They have low densities and are compressible. Mostly empty space, like I just said with the water bottle. They fill up the empty space. That's what gases do. All of these I like to picture in a water bottle. We can compress them. Most definitely, we can squeeze a water bottle. Gases exert pressure on their containers. Really kind of the same thing as the first one, that they expand to fill their containers. It just means that they're pressing out or from in to out on whatever is keeping them in. Any questions on any of those behavior of gases? No. So, we're going to start talking about gas laws, both in this class and our next class. What are gas laws? They are laws that state the mathematical relationships between the volume, temperature, pressure, and quantity of a gas. Got a question? We're going to do this one first. So I get the top. This is going to get a second one first. Yep. So, okay, so these five are going to be your 5 here. So why don't you start with us? Which is right here. This numbers right here. Those blinks that are highlighted. And then we'll come back to those. Just in case you have to have a private conversation about something. Thanks for the heads up. Yep. Go like everything you say. So moving on. Sorry, I got a little distracted there. But we touched on volume, pressure, temperature, and quantity of a gas. Those are the 4 things that were on that last slide. Today, we're only going to be looking at volume and pressure. So the one gas law we're going to go over just deals with volume and pressure. In the relationship of volume and pressure, it says as volume goes down, pressure goes up, as long as the temperature and number of particles stay the same. So if one goes up and one goes down, we would call them inversely related, right? Which means they do the opposite. If they both went up or both went down, we'd say that's directly related. But since one goes up and the other goes down, that is inversely related. Once you get those filled in, we're going to use the bottom right corner of your note sheet as some space. We're going to sketch this graph. Doesn't have to be super precise, doesn't have to be super artistic. As long as your graph can show the trend of the same thing I've been saying, that as volume's at its highest, so when it's here next to 1,200, its pressure is a very low number, it's a 1. But as the volume decreases or volume goes down and gets closer to the number 300, our pressure is now at 5. So our pressure went from 1 to 5, it went up. So instead of it being in words, that graph is just a visual to help you see that as one goes down, one goes up. We're going to get into some math problems later on today. That's why we have calculators. But every time you do the math problem, since we're comparing volume and pressure, you can look, if both of your numbers went down, if both volume and pressure went down, you didn't do something right. Something wasn't set up right, because one goes down, one should go up. They shouldn't be the same. I'll give you guys a few more seconds to get that graph copied. Like I said, you don't got to be super accurate. As long as it kind of shows that rough trend or the rough line going up to, up on the left and down on the right. Just open space there is fine. Just kind of draw the graph.
Did you draw the graph?
The volume on the left and the pressure on the bottom, and kind of show it swooping down. Just in the open space on that bottom right of your paper.
Right here. What's this?
Let's finish up drawing our graphs and we'll move on. So like I said, we're only going to be talking about one gas law today. The one gas law that we are going to be going over is Boyle's law. Now, Boyle's law says that if the temperature of a gas remains constant and the number of particles, the pressure exerted by a gas varies inversely. Remember, that means opposite as the volume. We're going to kind of hammer that home in these next few slides, is that we can remember that the volume and the pressure change inversely to each other or opposite to each other. It'll help us not only remember which law we're talking about, but it also is going to help us check our math problems to make sure we didn't do something wrong. So, same as the graph, just kind of a visual to help us see this. This cylinder, tube, whatever you want to call it on the left, notice the thing at the top is pulled towards the top, so the space is bigger. It has a bigger volume. The particles of the gas are spread out. It takes up that entire cylinder. And because that volume is pretty big, that pressure is going to be smaller. However, on the cylinder, tube, whatever it is on the right, it's pushed down. It's now a much smaller volume. All those particles are packed close together. So is that going to have a higher or lower pressure? Right, higher pressure. Volume went down, so we'd expect pressure to go up. This next one's a chart on your guys' thing. I think the only thing you have to do is draw the red arrows in there. All it's showing, and it'll make a little bit more sense when we start our math problems here in a slide or two. The red one's in the middle. You don't see red? Yeah, there are arrows in the middle. You're good. So what it's doing is it's showing that if we had two volume numbers, if we had a volume 1 and a volume 2, which volume 1 is initial, volume 2 is our final. If the change between those went down, so volume 2 is smaller, then we would expect our pressure to go up, or the difference between our pressure 1 and pressure 2 to be positive. And like I said, we're going to see those when we start writing our math problems and start solving for them. So here's our formula for Boyle's law. It says volume 1 times pressure 1. Remember from algebra that if two variables are ever touching, or if two numbers are ever just sitting next to each other with no sign, that's multiplication. So we have volume 1 times pressure 1 equals volume 2 times pressure 2. It really doesn't matter what order your volume and pressure are in. I think your other worksheet has P1 times V1. It's multiplication, those can flip. As long as you have both of them that are 1 on the left side and both of them that are 2 on the right side. That's the important part there. And again, it'll make a little bit more sense when we read our first word problem. But V1, it says old volume, and that means initial. That's what you start with. Same thing for P1, that's what we start with. Where volume 2, so V2 and pressure 2 for P2, when it says new, that means like after a change, that's what we have now, or our final pressure and volume. Okay, once we're done with that, that's it for the first page. We can go ahead and flip it over, and we have 2 word problems to do on the back of this. Now I'm going to do the first one. I'll walk through it. I'm going to draw it all on the board. Then you guys are going to have to do the second one. You can use people next to you, and then we'll kind of go over that one as a class. But for the first one, it says a sample of oxygen gas has a volume of 150 milliliters when its pressure is at 0.947. What will the volume of the gas be at a pressure of 0.987 if the temperature remains constant? So last semester of physical science, if you were here, you might remember Shirky taught you a process to solving these problems. The step 1, or the first step of the process, was to list your knowns and unknowns. Great. So if we remember our formula, which is P1 V1 equals P2 V2. Those are going to be our 4 variables. Now the first thing I have to do is read the problem and figure out where my variables are, right? Which of these numbers stands for V1 and P1 and all those. So if I go through and read it again, this is a sample of oxygen gas, has a volume of 150 milliliters when its pressure is at 0.947. So that's first, right? That's what it is right now. It's giving me a volume and it's giving me a pressure. So since that's what I have first, that's what I have to start. Do you think that's going to be my volume and pressure 1 or volume and pressure 2? 1 or 2? 1. That's what we start with. That's going to be our first. So it gives us a volume of 150 milliliters. That's going to be my V1, V for volume. And our pressure of 0.947. P for pressure. It says then, what will the volume of the gas be at a pressure of 0.987? So it gives us our second pressure of 0.987. And it's asking us to find volume 2. Yeah, it doesn't give us a number for volume 2. It's only going to give us 3 numbers in total. So one question? Okay. Once we have all the knowns and unknowns listed, we have our 3 accounted for that we know, and we've identified the 1 that we don't. Our second step is to rewrite our equation. So on the screen there, it shows the equation. It's P1 times V1. I'll switch markers. That's kind of going out. P1 times V1 equals P2 times V2. If we want to solve for V2, which is the letter on the far right, we got to get that alone, right? So we have to take P2 and move it over to the left side. If I want to do that, I have to do the opposite of what it's currently doing. Remember I said if they're ever next to each other, that means they're multiplying. So I need to divide it. I need to do the opposite of multiplying. So I will divide that side by P2. And once I do it to one side, I always have to do it to the other side. So I'm going to divide both sides by P2. On the right here, I have P2 divided by P2. That'll just cancel out, because that'll just be 1, and any number times 1 stays the same, so I don't have to worry about that side. And my left side I can rewrite nicely as P1 times V1 divided by P2 is all going to equal our V2 number that we're looking for. So that was step 2. So once I have the equation rewritten, now I can go on to solving. Well, to start solving, all I have to do is plug in the numbers that I already know for my one side of the equation. The first one is P1, which I know is 0.947, times V1, which I know is 150, and it's all divided by P2, which I know is 0.987. Catch up on the slides. So if I put that all in my calculator, which everyone should have a calculator, so let's try it. If you take 0.947 times 150, I always like to hit equals to give us our number, and then take that divided by 0.987. Once someone does that, let me know what answer you get. 143.92. Was that right?
Yeah, 143.92.
143.92. Now I heard ml. That's great. That's our label. We know we're finding volume. So we look at our other variable for volume, or other number for volume, and it gives us the label of milliliters, or ml. So I can just keep that the same. Now, in this problem, it gives us the type of gas. It doesn't always, but if it does give us the type of gas, we want to be super accurate, and it's talking about the volume of O2 gas or oxygen. We can throw that in there. Now, on your Canvas assignment, it asks for something a little different, so I want to kind of walk through that with you guys so you're not blindsided and miss a bunch of points. So make sure you remember this part for your Canvas assignment. It does not want to label. You will not have to put that in the Canvas assignment. If you do it, we'll count it wrong. Second thing, it also tells us to round to the nearest whole number. It doesn't want any decimals in there in any of the answers. It wants all of them in a whole number. So to do that, I look at the number that comes right after my decimal place. If that number is 5 or bigger, I'm going to round my number up. Well, a 9 is definitely bigger than 5, so I'm going to round this number 3 up to a 4, which will make my new answer 144. And that's what we'll put in Canvas. Any questions on that first problem, on that example 1? Great. If there's no questions, let's go 6 minutes. Everyone try to work out question 2. It's just the next question on there. Try to do the same process. First find your unknowns and unknowns, then rewrite the equation, then solve. And I'll be kind of walking around. If you have a question, raise your hand. I'll come help you out. But everyone should be trying the second one before I go over it. Once you get done, if you want to run the answer by your partner or whoever's sitting next to you, see if you guys got the same thing, that'd be great. Keep working. Like I said, if you're done, compare it with someone next to you, or raise your hand. I can come look at the right answer too. Yeah. Just grab the pen. Yeah, we'll have to get some. Just what's the number? Wait till he gets back then, yeah. What'd you get for his? What'd you get for his? Okay. We don't want to go get rid of that decimal. Harley, what's up? So we're not adding them, right? We're not adding them all up. We should be. So we're taking this one, 1.26, times 7.4. So do that one first. 1.26 times 7.4. Blue, go. You can go. And then take it divided by 2.93. Yep, that's it. That's what we should be getting right there. Okay, it looks like most people are about wrapping up, so I'm gonna head and go over it. I'm not gonna go as slow as I did that previous time, but we start with our knowns and unknowns. What does it tell us volume 1 should be? Everyone just pretty much worked this out on their paper. So what did you guys put for volume 1? 7.4? Okay. What about pressure 1? 1.26? What about pressure 2? What was pressure 2? 2.93 for pressure 2? Right, that's our unknown. Pressure 2 is what we're looking for. Make sure we're listening, even if you haven't done. Make sure it's right. Eyes up here for just about 2 more minutes, and then we're done with this sheet. Our volume 2, what was that number? 2.93? Yep. Okay, now we rewrite our equation. We're solving for P2, so now we got to move V2 over. So we divide both sides by V2, we do the opposite. That's the equation we should be getting. Everyone compare it to your sheet, make sure it's right. If it's not, go ahead and change it. Because here we're solving for P2. Once we get that equation, we start plugging our numbers in. 1.26 for P1 times 7.4 for V1. All that divided by V2, which is 2.93. And for those of you that got it done and did in your calculator, what'd you get for an answer? What'd your calculator say? 3.1. 3.18. Now, if we were putting a label on it, what would our label be? ATM. Yep. Now, and I saw most of you did it, for your Canvas assignment, it's going to ask for you to round to the nearest whole number. That 1 rounds down, so we keep that 3 the same. So our answer we would enter in Canvas would just be 3. Any questions on that? Okay, if there's no questions on that, that's it for that paper. Go ahead and grab your other paper that says Boyle's Law at the top and kind of like bubble letters-ish. Shirky, where's your notebook at? Oh, I got it. It's just under everything. So yeah, one of the kids walked off with it. Okay, so up on here on the screen, here's what we're going to be putting on this paper. It gives at the top another definition of Boyle's law. It says at constant temperature for a fixed mass, the absolute volume and pressure of a gas are inversely proportional. Just another type of definition, another way of saying that if volume or temperature and the amount of gas stay the same, pressure and volume are inversely related. Once you're done writing that, and we should all be filling this in, everyone has this paper.
So it says at a constant temperature. That's the first one, constant temperature.
Once you're done filling that top part in, go ahead and shade these beakers roughly how the beakers are shaded on the paper. Again, doesn't have to be super perfect. This is not art class. All I want you guys to see is that the beaker on the left is more full, so it has a bigger volume than the beaker on the right. And if you look at the numbers on the bottom, which is the pressure, on the left side the pressure is 10, on the right side the pressure is 40. So the pressure is increasing, moving to the right. At the same time, the volume in the beakers is going down or getting smaller. Like I said, just hammering home the fact that they change opposite to each other. As one gets bigger, one gets smaller. Just a bunch of different ways. Hopefully one of the ways works best and kind of locks into your brain and helps you understand it. And then this little arrow over here to the right just says inversely. Once you get back to your sheet, you want to copy this on down on the second sheet. Once you guys are done copying that down, listen up real quick. Voice is off 1 sec, and then I'm done for the day with you guys. It's up to your time to work. Carter, make sure we're listening 1 second. Once you're done copying stuff down, there is a 15-question assignment on Canvas. If you go to the Wednesday tab on the homepage, it's the bottom link. There's 15 problems of the math ones, just like we did in our worksheet. Read them carefully. Some of them ask you to solve for volume 2 or pressure 2 like we did in ours. Some of them will ask you to solve for one of the volume 1s or pressure 1s. You have to read the problem and figure out which one they're asking you to solve for. So take your time reading it. If you have any questions on them, raise your hand. Either I or Mr. Shirky will come around and help you. Other than that, we're done for notes and everything. The rest of the class is for you to do your assignment. I think Lugo's stuck up and down. I'm using the bathroom. Okay. Yeah, I'll give it to you.
Yes.
Bradley.
What do you need?
Word of the date sheet.
Yeah. There you go. Yep.
Boyle's law.
Need me to read it to you, Lugo? It says inversely. Yep. Is that it for you? You done? Okay. Anyone else still copying down what's on the screen, or is everyone done? Everyone's done. All right. There you go. Project, extend.